Hello and welcome to Algebra 2 Lesson 40. In this video, we're going to learn about factoring out the GCF, otherwise known as the greatest common factor. Now, before we actually get into factoring, I need to review something known as the greatest common factor, or the GCF. This is how we abbreviate that. So this is the largest term that each term of the polynomial is divisible by. So I want to start out with a brief example. So we want to find the GCF for 6x squared, 12x, and then 18x to the fifth power. So for the number part, we've been doing this since pre-algebra, okay? If I wanted to find the GCF for 6, 12, and 18, a lot of you at this point can eyeball that and say, well, I know it's 6, right? Because 18 divided by 6 would be 3, 12 divided by 6 would be 2, 6 divided by 6 would be 1, right? So that's easy to do at this point for us, but if you have no clue on how to do it, the official procedure would be you take each number and you find the prime factorization. So 6 would factor into 2 times 3. 2 is prime and so is 3. 12 we could factor as 4 times 3. 3 is prime. 4 is going to be 2 times 2, and 2 is prime. Then next we have 18. So 18 I could write as 9 times 2. 2 is prime. Then 9 is 3 times 3. 3 is prime. Now, once we have the prime factorization for each number, what we're looking to see is what prime factors are common to everything, okay? Common to everything. So to make that crystal clear, I could write 6 right here as 2 times, and I'll put a big space out here, times 3. I could write 12 as 2 times 2 times 3. And then I could write 18 as 2 times, leave my space, 3 times 3. Now the way I've written it here makes it easy to see what's common to everything. Everything has one factor of 2. Everything has one factor of 3. So to get my GCF for 6, 12, and 18, I just take the prime factors that are common to everything and I multiply them together. 2 times 3 is 6, okay? So 6 would be your GCF. And the reason for that is because everything involved has those prime factors when the number is built. So in other words, 18 has a prime factor of 2 and a prime factor of 3. So I know 18 would be divisible by 6. Same thing with 12. I know it would be divisible by 6. And then same thing with 6. I know it would be divisible by itself, 6. So again, the GCF is 6. So let me erase all that. All right. So when we think about our GCF, I'm just going to put 6 right here, and then I'm going to put a question mark for the variable part. The variable part is pretty simple overall. You have x squared, you have x, and you have x to the fifth power. Now, you could go through and do the same thing. You could factor x squared and say x squared is x times x. Then x is just what? It's just x. And then x to the fifth power is x times x times x times x times x. You can go through and say what's common to everything. Well, just one factor of x. So the variable part is just 1x. 1x. But what's the quicker way to do that? Well, when you have variables involved, the first thing you want to check to make sure of is that everything has that variable. In other words, this has an x, this has an x, and this has an x. Then you're just going to look for the smallest exponent. In this case, the smallest exponent would be this one, right? The understood exponent of 1. The reason you look for the smallest exponent, that's going to tell you the fewest number of factors of that variable that you're going to have. In this case, I only have 1x here. Everything else, if this is the smallest, will have at least that. And so that's going to be common to everything. So my GCF here would be 6x. All right, let's take a look at another one. Let's say I had 14y squared x, 21x cubed y squared, and 42x to the ninth y cubed. Now, again, a lot of you can kind of eyeball this and look at the numbers and say, well, I know that 42 is divisible by 14. It would be 3. I know that 21 is not divisible by 14, but I know that 21 and 14 would share a common factor of 7. So my GCF for the number part would be a 7, because 14 is divisible by 7, 21 is divisible by 7, and 42 is divisible by 7. Right? So once you have enough experience, you can kind of eyeball things. and say, I know what my GCF is. But for right now, I want to just go through it the long way. For those of you who were a little confused about what I just did. If I think about 14, it's what? I could factor it into 7 times 2. 7 and 2 are both prime numbers. If I think about 21, I could factor it into 7 times 3. 7 and 3 are both prime numbers. If I think about 42, I could factor that into 7 times 6. 7 is prime. 6 I could factor into 2 times 3. 2 and 3 are both prime. So look at what's common to everything. Everything has 1 7. And then this does not have a 3. This does not have a 2. So a 2 would not be common to everything, and a 3 would not be common to everything. So I can only take what's common to everything, and that's a 7. So for the number part, the GCF would be 7, and then you have some variable there. All right, so let's erase this. Now for the variable part, I see that I have the variable y, and I have the variable x involved. Now I have an x and a y in every term here. So I'm just going to pick the smallest exponent on each. So I'm just going to write x, and I'm going to write y, and then I'm going to write the smallest exponent that appears on each. So here, for x, I have x to the first power, I have x cubed, and I have x to the 9th power. So the smallest exponent is a 1, so this just stays as x, or you could write x to the first power like that if you wanted to. For y, I have y squared, and y cubed. The smallest exponent that appears on y is a 2, so this would be y squared here. So my GCF here is going to be 7x y squared. Well, let's do one more of these, and then we'll get to some factoring. So we have 25z to the 4th power y squared, we have 10z, and we have 50zy. So for the number part, again, try not to get into a factor tree. Just notice that everything here is divisible by 5. All right, we think about our divisibility rules. I know everything ends in a 5 or a 0 here. So 25 divided by 5 would be what? That would be 5. So we know this is 5 times 5. 10 we know is what? 5 times 2. 50 we know is 5 times 10. Now, 10 is what? It's 5 times 2. So let me write 5 times 5 times 2. So I've factored each number here, but I can kind of do that in my head, and I know you can as well, especially with these smaller numbers. Everything has 1 5. Everything does not have a second 5. And then everything does not have a 2. So really the only prime factor that's common to everything is 5. So for my GCF, the number part would be a 5, okay, and a 5 only. All right, for the variable part, we see we have z and we have y involved. Now, I have a z here, and a z here. The smallest exponent that appears on z is a 1. Right? You have a 1 here and a 1 here. So I just put z. Now for y, I have y squared here, and I have y to the first power here, but I don't have a y here. So it's not common to everything, okay? And if it's not common to everything, it can't go into the GCF. The GCF is the largest term that each term here would be divisible by. So each term here would not be divisible by something with a y in it because there's no y here, okay? So the GCF is just going to be 5z. So now that you know how to find the GCF for a group of terms, let's talk about how to factor out the GCF from a polynomial. To do this, I'm going to start out with a very simple example. Let's say you had 6 plus 15. And what I would do is I would write 6 as 2 times 3. And I would put plus 15 I'd write as 5 times 3. All we're doing is we're just kind of reversing the distributive property. Notice that I have a 3 that's common to each, right? 3 is the greatest common factor between 6 and 15. All I'm going to do is pull that 3 outside of a set of parentheses. So 3 goes here. And then in these spaces, I'm just going to have what's left. I pulled out a 3 here, so I'm just going to have a 2 that's left. I pulled out a 3 here, so I'm just going to have a 5 that's left. And you can think about reversing this. If I did 3 times 2, I'd be right there, right? And that would give me 6. Then plus, if I did 3 times 5 or 5 times 3, it's the same thing, I'd have that, which would give me 15. So instead of kind of going this way, like I'm normally doing, I'm just kind of going backwards, right? I'm reversing the distributive property. All right, so let's look at the first example. So we have 4x plus 12. The first thing I'd want to do is figure out what is the GCF here. What is the greatest common factor? Well, I know there's going to be no variable involved because I have an x here, but no x here. Remember, it's got to be common to everything. So I'm just looking at a number. And this one's very easy because I think about 4 and I think about 12. I know that 12 is divisible by 4. 12 divided by 4 is 3. So the greatest common factor here would just be 4, right? 4 divided by 4 is 1. 12 divided by 4 is 3. And again, if you needed to see that, you could break that down the long way. You could go, okay, well, 4 is 2 times 2, and 12 is what? It's 4 times 3. 4 is 2 times 2. So really, I have 2 factors of 2 here and 2 factors of 2 here. So each one here is going to be divisible by 4. So the greatest common factor is going to be a 4. All right. So once we've figured that out, all I need to do for this example is pull a 4 out. So I could write this as 4 times x like this, just to completely show what's going on, plus, if I divide 12 by 4, I get 3. So 4 times 3. And this would be equal to, just pull the 4 out, place it outside of a set of parentheses, and in the parentheses would have what's left. Here it would just be an x, plus here it would just be a 3. The other way you could think about that, remember, multiplication and division are opposites. So I know if I do 4 times x, I get 4x. I know if I do 4 times 3, I get 12. So I could reverse that and say if I'm pulling a 4 out from here, well then 4x divided by 4 would be what? That would be x. So that's going to go right there. I could do 12 divided by 4, and that would give me 3. So that's going to go right there. Right? I'm just thinking about multiplication and division as their opposite operations. So that's another way you can do that. And that's, in fact, what you're going to do when you do this mentally. When I factor this now, I just look at it and I say, okay, well, I know that 12 is divisible by 4. So 4 is the GCF. That's the first thing I come across. Then after I put 4 outside of a set of parentheses, I would say, okay, well, 4x divided by 4 would be x. That's how I get my first term. Then I put my plus, and next I say 12 divided by 4 would be 3. That's how I get my second term there. All right, let's take a look at another one. So I have negative 2v to the 5th power plus 5v cubed. So if I think about negative 2, it's just negative 1 times 2. 2 is a prime number. 5 is a prime number. There's nothing common there number-wise. So in my GCF, I'm not going to have a number involved other than I could use 1. And we'll talk about this later. I could also use negative 1 if I wanted to. Okay, I'm allowed to factor that out. But for right now, I'm not going to think about any numbers. I'm just going to look at the variable. I have v to the 5th power and I have v cubed. So everything has a v. The smallest exponent is a 3. So I know that's what I can factor out, a v cubed. So let's put equals. We'll put v cubed. And then inside, I'll have 2 spaces here. Again, I could write this the long way and say I have negative 2 times v cubed times v squared plus 5 times v cubed. I could circle v cubed. Okay, a lot of students like to do this. And say, okay, if I pulled that out, what's left? Well, here it's just negative 2 times v squared. Plus, here it would be 5. Okay, you could do it that way. Now, another way you can do this, again, if I don't know what this is, let me just erase this. I can just use division, okay? I could say, well, if I have negative 2v to the 5th power divided by v cubed, what's that going to give me? It's going to give me negative 2. V to the 5th power over v cubed is v squared. So that's what goes here, negative 2v squared. And I would do the same thing with this term. I would say 5v cubed divided by v cubed is equal to what? Well, again, I have 5. V cubed over v cubed is 1. So I'd get a 5 there. So you could use division, or you can kind of separate things with multiplication where it's obvious what's going to be placed in here for these terms. Whatever is more comfortable for you. I can tell you that you're probably, as you get higher in math, going to use division. Okay? It's just easier to do that. It's more efficient. And in most cases, you're going to use division in your head. We know if we wanted to check this, we could use our distributive property. V cubed times negative 2v squared would give me back to negative 2v to the 5th power. Then plus v cubed times 5 would be 5v cubed. So good to go there. All right, let's take a look at the next example. So suppose we have negative 8x cubed plus 12x. So we think about the numbers here. I have negative 8, which I'm going to write as negative 1 times 8. 8 is what? I think about that as, let's write negative 1 times 2 times 2 times 2. We should know at this point that 8 is 2 cubed. For 12, we have what? We have 4 times 3, right? 4 times 3. So 4 is 2 times 2, then times 3. So kind of a quicker way to approach this would say, okay, well, I have negative 8 here. So just think about 8 for a second. And then I have 12. So both of those are even numbers. And I would say, well, I know that 12 breaks down into 4 times 3. I know 8 is not divisible by 3, but it is divisible by 4. And so right away, I figured out that 4 is my GCF. But if you have to do this the long way for a little while, that's fine. You see that you have 2 factors of 2 there, 2 factors of 2 there. That's what's common. And 2 times 2 is 4. So my GCF here, the number part is a 4. All right, for the variable part, we have an x cubed and an x to the first power. Again, it's common to everything. We go with the smallest exponent, which is 1. So this is 4 and then x. All right, so if we want to pull this out, we would say this is equal to, and let me kind of scooch this down. We'll put our 4x outside of a set of parentheses. Put my 2 spaces in there. What goes here and here? Let's just use division. Okay, let's just use division. So if I had negative 8x cubed divided by 4x, negative 8x cubed divided by 4x, negative 8 divided by 4 is negative 2. And then x cubed over x is x squared. Okay, and with that, next let's use 12x. And let's divide that by 4x. We know that 12 over 4 is 3. X over x is 1. So this is a 3 here. Okay. And again, if you use multiplication, you'll get back to this. 4 times negative 2 is negative 8. X times x squared is x cubed. Then plus, we have 4x times 3. 4 times 3 is 12. X comes along for the ride. You get 12x back. So our answer here is correct. 4x times the quantity negative 2x squared plus 3. All right, let's take a look at another one. So we have 8x to the 6th power plus 80x to the 6th power y to the 4th power plus 40x to the 9th power. So I want you to kind of eyeball this, and I want you to, without doing a prime factorization, pause the video and see if you can figure out what the GCF is. I think that you can do that. Okay, so I'm going to assume that you tried that. And really the method that I would use, I would see that I have an 8 here, an 80 here, and a 40 here. Everything you should notice here is divisible by 8. 8 divided by 8 is 1. 80 divided by 8 is 10. 40 divided by 8 is 5. So that tells me right away that the GCF, the number part at least, will be an 8. Now, for the variable part, I have an x, an x, and an x. I have a y here, but I don't have a y anywhere else. So the GCF will only contain an x, and then the smallest exponent is a 6, right? I have a 6 there, and a 9. So 8x to the 6th power is my GCF. So to factor this, let's put equals. We're going to put 8x to the 6th power out in front. And inside the parentheses, I'm going to have 3 spaces. So what's going to go here, here, and here? Well, all I'm going to do is I'm going to take that GCF, and I'm going to use it as the divisor of each term here. So in other words, I would start out with 8x to the 6th power, and I would divide it by 8x to the 6th power. Of course, 8x to the 6th power over 8x to the 6th power is 1. And next we'd have plus. So I'd move to this next term. I'd have 80x to the 6th power, y to the 4th power, divided by 8x to the 6th power. So I know that 80 divided by 8 would be 10. So a 10 would go there. X to the 6th power, x to the 6th power is 1. And then you'd have y to the 4th power. Okay. All right, let's do one more here. We have 40x to the 9th power. So 40x to the 9th power. We're going to divide that by, again, the GCF of 8x to the 6th power. We know that 40 divided by 8 is 5. X to the 9th power over x to the 6th power is x cubed. So this would be 5x cubed. Now you can check this if you want to. Again, you would use your distributive property and just kind of reverse this, and you'll get back to this. All right, so our answer here, we have 8x to the 6th power times the quantity. We have 1 plus 10y to the 4th power plus 5x cubed. All right, let's take a look at another one. Let's say you had negative 28x to the 4th power, y to the 4th power, plus 24xy cubed, plus 32xy squared. So again, if I think about the number part here, without making a factor tree, without going through all that, just think about some things that we notice. The first thing I notice is that everything is an even number. So I know everything would be at least divisible by 2, okay? Now, the next thing I would check and say, is everything divisible by 4? Yeah, it is. Forget about this negative for a second. Pretend it doesn't exist. 28 divided by 4 is 7. 24 divided by 4 is 6. 32 divided by 4 is 8. The fact that this divided by 4 is 7 is a big thing. 7 is a prime number, okay? So I know that I can't further break this down. It's just going to be 2 times 2 times 7, okay? So let me just write that right here real quick. This is 2 times 2 times 7. And if I consider that negative, it's really negative 1 times 2 times 2 times 7. Now, if this is not divisible by 7, which it's not, and this is not divisible by 7, which it's not, I'm done, right? I know that everything will only have a 4 in common, okay? So I can stop and say my GCF, the number part at least, would be a 4. Now don't get me wrong, there's times where you get really big numbers and you have to make a factor tree. You can't get around that. But in simple cases like this, you should be able to eyeball these things and come up with your GCF, okay? And you're going to be expected to do that, especially as you move up and you start taking standardized tests, right? It's going to be built into the time limit. All right, so now I think about my variable part. I have an x everywhere and I have a y everywhere. So x, the smallest exponent would be a 1, so I'd put an x there. And then for y, the smallest exponent would be a 2, so I'd put y squared. So my GCF is 4xy squared. All right, so if I want to pull that out, let's kind of scroll this down. Let's put equals, which we already did, and then 4xy squared outside of a set of parentheses. And we'll have 3 terms in here. And again, to get the terms, I just take each term and I divide it by the GCF and I get the term, right? Because again, division is the opposite of multiplication. So if I multiplied, I'd go back to what I had, okay? So negative 28, okay, negative 28, x to the 4th power, y to the 4th power, divided by 4xy squared, 4xy squared. We think about negative 28 divided by 4 is negative 7. So this is negative 7. We think about x to the 4th power over x. This is x cubed. And we think about y to the 4th power over y squared. This is y squared. So this would be negative 7 x cubed y squared. All right, for the next one, we have 24 xy cubed over, we have 4xy squared. Okay, so let's look at this. 24 divided by 4 is 6. X over x is 1. Y cubed over y squared is y to the 1st power. So this is 6y. And let's erase this. And we'll do our last one now. So we have 32xy squared over 4xy squared. So 32 divided by 4 is 8. X over x is 1. Y squared over y squared is 1. So I'm going to put an 8 there. All right, so let's erase this real quick. And we see our answer is 4xy squared times the quantity. We have negative 7x cubed y squared plus 6y plus 8. Now, if you wanted to check to make sure that you factored this correctly, you could use your distributive property and distribute this 4xy squared to each term, and you can see that you get this polynomial up here back. All right, so the next thing I want to talk about, we have here that in some cases, we may prefer to factor the negative of the GCF. So this is something that might be very useful for you. In fact, in the next section, when we start reviewing factoring by grouping, a lot of times we'll use the negative of the GCF to end up with a common binomial factor. So When we talk about pulling out the GCF, we could do the GCF or the negative GCF, and it's still the same thing in terms of getting the correct answer, okay? So if I look at something like this, we have negative 25x squared y cubed, negative 15x squared y to the fifth, and negative 50x cubed y cubed. I could pull that negative out to start, okay, if I want to. When I do that, I'm going to have the negative GCF, not the GCF itself, right? When we think about the greatest common factor, we know that the positive version is larger than the negative version. So that's why we say the negative of the GCF when we do something like this. Now, if I think about what the GCF is here, think about 25, 15, and 50. They're all divisible by 5, right? 25 divided by 5 is 5. 15 divided by 5 is 3. So I can stop there. I don't even need to go there. I know that these two only share a common factor of 5, and this one also has a factor of 5, so I can just put 5 down. Again, if I'm doing the GCF, I want positive 5. But because it's convenient, if I want to do the negative of it, I just do negative 5, right? And both answers are acceptable. Now, when I think about the variable part, I've got x squared, and x cubed. So the smallest exponent is a 2, so I go with x squared. Then I've got y cubed, y to the fifth, and y cubed. The smallest exponent is a 3, so I go with y cubed. So inside the parentheses now, these won't be minuses anymore. They'll be pluses, okay? And why is that the case? It's because I pulled the negative out, right? So everything inside will now be positive because negative times positive would bring me back to negative. Negative times positive, bring me back to negative. Negative times positive, bring me back to negative. Very important you understand how to deal with signs when you're factoring, okay? So I'm going to do some division. Negative 25x squared y cubed divided by negative 5x squared y cubed. What do I get? Negative over negative, again, is positive. 25 over 5 is 5, and then these cancel themselves out. So this first position here is a 5. For the second position, I would have negative 15 x squared y to the fifth power over negative 5x squared y cubed. So negative 15 over negative 5 is going to give me positive 3. X squared over x squared is 1. Y to the fifth power over y cubed is y squared. So this would be 3y squared. And then lastly, we would have negative 50 x cubed y cubed over negative 5x squared y cubed. And so negative 50 over negative 5 is 10. X cubed over x squared is x to the first power. Y cubed over y cubed is 1. So this would be 10x. So 10x. Now, what you could have done, again, this is what I'm trying to do here, is explain to you that I didn't have to factor out this negative. I could have said the GCF is 5x squared y cubed. So I could have just factored out a positive. The only difference is all the signs in here would change. This would be negative, this would be negative, and this would be negative. So it's just a matter of preference, okay? What do you want it to be? If I wanted to pull the negative out, I'm allowed to do that. That's all I'm telling you. You could factor out the GCF or the negative of the GCF, and it's still going to be an acceptable answer either way.